Hello guys, I'm going to teach you about normality, molarity, molality, formality. These are the common basic terms of chemistry which we have to know. So all the students must know these terms because these are very popular in doing the calculation of normal chemistry, physical chemistry. So first of all, what do you know about normality? Normality is all about gram equivalent weight in a liter of solution. That means when we have gram equivalent of solute divided by the volume of solution in a liter. Because for the solution we need the terms solute, solvent, then we can make a solution. So here the normality is the gram equivalent of solute divided by the volume of the solute in liter. So how can we measure it? The gram equivalent of solute. For the gram equivalent of solute, we need the weight divided by the equivalent weight. Equivalent weight means the molar mass divided by N. Suppose we want to calculate the equivalent of weight of sodium. That means the molar mass of sodium is 23 and the N means how many electrons it can donate or accept. So as we know, sodium can donate only one electron. So the number of N will be 1. So the equivalent weight of sodium will be 23. So the volume of the solution in liter. As we know, 1 liter is equals to 1000 ml. That's why we can easily calculate the normality of a molecule like this. So next we have to go for an example like this. What is the normality of a solution containing 0.40 mole of sulfuric acid in 600 ml of solution? So at first we have to calculate the equivalent to it. Like here the mole is 0.40 mole. 0.40 mole and sulfuric acid it can donate 2 protons like H2, SO4. So it can donate 2 hydrogen ion. So that's why we can place the N 2. So here comes 0.80 equivalent. So in the upper numerator we have to give the 0.80 equivalent and the volume of the solution is 600 ml. That means if we want to convert it in liter, it will be zero point 0.6 liter. So 0.8 divided by 0.6, that means 1.3 normal. So the normality of the solution will be 1.3. Our next slide is about molarity. Molarity means mole divided by the volume of the solution. Number of moles of solute divided by volume of the solution in liter. So on the upper side there will be mole and in the denominator we will say it will be volume. So suppose we have an example like this. We have to calculate the molarity and the volume of the solution is 400 ml and the moles of the solute is 0.2 mole. So the molarity will be simple like this: moles of solute divided by liter of solution. Here 4000 ml, that means 0.4 liter. If we divided it 1000 ml. So 0.2 mole divided by 0.4 liter, that means 0.5 mole or the semi-molar solution. Our next term is molality. Molality means Moles of solute divided by kg of solvent. Here the volume of the solvent is in kg. That means 5 kg in 500 kg or 10 kg in 1000 kg. Both of the term will be in weight. That's why it doesn't depend on the temperature. The molarity and the normality depends on the temperature. As we know, if we apply the temperature, the volume will increase or decrease. We know that. But here in the term molality, there is no volume. That's why it will not depend on the temperature. So if we go for a problem, calculate the molality of a solution prepared from 29.1 gram of toluene dissolved in 832 gram of benzene. So we have to calculate the molality. So here the mole of solute divided by kg of solvent. What is the solvent? We have to dissolve the toluene into the benzene. That's why the benzene is the solvent here. The amount of benzene is 832 gram and the amount of toluene is 21.1 gram. So at first we have to calculate the mole of toluene. So to calculate it, we have to divide the 21.1 gram divided by the mass, atomic mass of the toluene. That means 92. We get a number 0.316. So the rest of the calculation is simple. 0.316 divided by 832 kg. That means 0.380. Mole fraction. So when we get the term fraction, that means it will be a ratio of moles of a solute to total number of moles. That means the moles of solute divided by the total moles of solution. So both of the terms are in moles, so we have to calculate the terms in moles. And for the solvent, we have to calculate the term solvent. Sorry. So the moles of solvent means moles of solvent divided by total moles of solution. So there is a theory that means the mole fraction of solute and the mole fraction of solvent, if we add the both of the terms, we will get 1. So if we calculate one term like the mole fraction of solute, we can easily calculate the mole fraction of solvent by divided it from 1. Suppose there is a question like this: if a mixture of gases contain 7.50 gram hydrogen, 3.25 gram oxygen, and 5.55 gram nitrogen. There are three terms: hydrogen, oxygen, and nitrogen. So, what is the mole fraction of each of the gases? So, if we want to calculate the mole fraction of the gases, as we know, we have to calculate it in mole. So, for the hydrogen, it is given 7.50 gram hydrogen. So, we want to calculate it in moles. That means in the upper side, 1 mole hydrogen divided by, as we know, the atomic mass of hydrogen is 2.02 gram. So we'll get 3.71 mole hydrogen. For oxygen, same. Atomic mass of oxygen is 32. So if we divided the gram divided by the atomic mass, we'll get the mole, 0.102 mole oxygen. Similarly, we can also calculate the nitrogen. Here we have to calculate the mole fraction of each gas. So this is a easy term. If we divided the atomic mass of the molecule with the given weight, we get the mole fraction of each gas. Our next term is formality. Formality terms means number of grams formula mass of ionic solute in a liter of solution. It is symbolized as F. The F is the number of formula weight of solute. So formula weight, what do we mean by that? Units of solute per liter of solution. What is the purpose of the formality? The purpose of the formality is to distinguish the number of moles of a compound from the number of moles of ions in a solution in ionic compounds. As we know, the sodium chloride solution, when it puts in aqueous solution, we get the sodium ion and the chloride ion. So the formality is about the ions. That means the number of gram formula mass of ionic solute in a liter of solution. Thank you. That's all about the basic terms: molarity, molality, formality. Thanks for hearing.